In the last lecture, we talked about how we describe the position of objects in a two-dimensional world. And we used the example of, for instance, a robot, and we created a two-dimensional coordinate frame. We've placed the coordinate frame at a reference location, and we can describe the position of the robot with respect to that coordinate frame. And we also talked about how we describe the orientation of the object. That's which way the robot is pointing with respect to the axes on this coordinate frame. Now what we're going to do is to kick it up a level of complexity and introduce the third dimension. So for most robotics, the third dimension is really important. The robot's hand, for instance, in any sort of real robot, the hand is going to move in a plane, but it's also going to be able to move up and down. So we need to be able to describe the position and orientation of bodies in three-dimensional space. But there are also a lot of robots that move in three-dimensional space. So here I have a model aeroplane, and of course an aeroplane flies through the air, it goes up and it goes down, it can move left and right. It can also rotate in a number of interesting ways. It can pitch up and down, it can yaw like this, and it can also roll like this. So underwater robots are another example. They're a bit like this, but instead of flying through the air, they're flying through the water. So these are two very important classes of robots today, robots that fly and robots that swim under the water. And their motion is described in terms of three-dimensional space, where it's a simple wheeled robot like this, we could get by with just describing its position and its orientation in terms of two-dimensional space.